Hi everybody. So today I'm going to be talking a little bit about the work I've been doing in the past year or so, as Neil said, as a technician. So we've been looking at screening for Lynch syndrome in skin tumours and small bowel tumours. So as we've heard this morning, there is currently NICE guidance in place to test for Lynch syndrome in every new diagnosis of colorectal and endometrial cancer. However, for sebaceous cancer and duodenal cancer, there is currently no guidance in place. So we wanted to determine if a low-cost assay could be used to screen for Lynch syndrome in these two tumour types, as we think it'll be an important step towards comprehensive Lynch detection. So as I've said, these are the two tumours that our group are interested in, sebaceous tumours and duodenal tumours. So sebaceous tumours are tumours that come from the growths in the sebaceous glands. Sebaceous glands are important for releasing oil to lubricate your skin and your hair. And duodenal cancer grows in the duodenum, which is just below the stomach in the first part of the small intestine. So why is it these two cancers that we're interested in out of all of the Lynch-associated cancers? Well, this is mostly based on a review led by Dr. Richard Gallen, who is one of our colleagues and also an active researcher in the Lynch syndrome space. And this paper reported that out of all of the cancers that they looked at, these two rare tumours were most likely to be associated with an underlying diagnosis of Lynch syndrome. And as you can see, the sebaceous tumours that were looked at in the study were linked to an underlying diagnosis of in Lynch syndrome of around 18% of cases, and 5% accounting for duodenal cancer. So we've heard this story quite a few times today, but just to set the scene for what our group is trying to do, it's important to understand the pathway that the patient undergoes to get tested for Lynch syndrome. And very, very simply, I'm going to sum these up into three main steps. So the first step of the patient journey is to have a mismatch repair test. In this test, someone will take a biopsy from a tumour to test to see if any of the proteins that the mismatch repair genes make are missing. So this is a really good clue as to whether someone has Lynch syndrome, because most of the time, if your mismatch repair genes are working totally fine, then they should be making the protein. And if the protein isn't there, that could be a sign that one of the genes isn't working properly. So alternatively, the patient can also get an MSI test using tumour DNA. So MSI stands for microsatellite instability, and this is another marker that will just give us a clue as to whether we are looking at a patient that has Lynch syndrome or not. So if the first or the second test show a sign of Lynch syndrome, then a germline test could be offered to the patient. And if this shows a genetic change in one of the mismatch repair genes, then a Lynch syndrome diagnosis would be confirmed. So the Cancer Prevention Group at Newcastle University, led by Professor John Byrne, in collaboration with the Newcastle upon Tyne NHS Foundation Trust, have decided to make an assay that is an alternative to these testing methods that we've just looked at, with the hope to reduce the cost and the timescale. So the assay itself has a really fast turnaround time, it's low cost, it's totally automated, and it's really easily scaled as well. And it's been in service in the NHS since October 2022 and is currently being implemented into other regions of the UK. So how does the test work? The first step is to take some DNA from a tumour found on a patient. We will then do the lab work following the guidelines from the Newcastle MSI Plus assay. And this gives us a diagnostic report. So this report is really interesting because it gives us insight to this marker that I looked at before called microsatellite instability. And then if that marker is flagged, we know we could be looking at a Lynch syndrome patient. So what we want to do is see if we can use this Newcastle MSI Plus assay to screen for Lynch syndrome in both sebaceous and duodenal tumours. We're going to do this by testing these tumours using the Newcastle MSI Plus assay, and we're going to compare the results that we get from that to the reference method already used in the NHS, which is immunohistochemistry. So with ethical approval, we've managed to get a hold of 110 sebaceous tumours and 50 duodenal tumours. As I said, we're going to do the MSI plus assay on these and then validate them results using the immunohistochemistry. It's also worth mentioning as well that the tumours that we've got a hold of are unselected and consecutive samples. So I'm going to go through some of the results that we've had so far. So these are the results for the sebaceous MSI plus assay. And just to explain what we're looking at here, so on this graph, every dot represents a tumour, and the Newcastle MSI plus assay can give each tumour something called an MSI score. So an MSI score, if it is above 0, which is indicated by the dotted line on the graph, we know that tumour is likely to be from a Lynch syndrome patient. On the other hand, if the tumour has an MSI score below 0, it's probably unlikely that this tumour is going to be from a Lynch syndrome patient. So far we've tested all 110 of the sebaceous tumours that we've got using the Newcastle MSI plus assay, and 43 of those sebaceous tumours had an MSI score above 0, which is 39.1%. So now looking at how that compares to the immunohistochemistry, out of those 43, 38 of them had enough tissue to do immunohistochemistry on, and 38 out of the 38 had shown a loss of expression of one or more mismatch repair proteins. And I've just put some circles on the picture on the side just to explain what we're looking at. This is a section of tissue that has had immunohistochemistry stain done on it. And when the person that's done this stain will look at it, the brown parts are where the protein is being expressed, and where you can see the blue parts, that means the protein is not being expressed. So moving on to the duodenal samples. So far, we've tested 31 out of the 50 that we've got using the MSI plus assay. And 8 of those 31 have had an MSI score above 0, which is 25.8%. And once again, we actually had enough tissue for all 8 of those samples to do immunohistochemistry, and all 8 of them showed a loss of expression of one or more mismatch repair proteins. So far we can conclude that the results from the Newcastle MSI plus assay have a high level of concordance with the immunohistochemistry on sebaceous and duodenal samples. The next steps for us is to test the microsatellite stable samples. So those are the samples that had an MSI score below 0, because we really want to determine whether this test is actually sensitive and specific to use to screen for Lynch syndrome in these 2 tumour types. And now I'll pass on to Neil for the next half of the